Hi, this is Benjamin, or MrStahlfelge. I'm the developer of the mobile Ergo wallet apps, and for this ErgoHack I wanted to introduce you into ErgoPay. Let's start with what is ErgoPay. ErgoPay is a dApp connector for non-web wallets, and we get to the topic of this ErgoHack with this because especially security-aware users don't like web extension wallets, because non-web extension wallets are or feel more secure because they have a better separation, are not integrated into the web browser users use for very different tasks not related to blockchain use, while a non-web wallet is only used and opened when they work with the blockchain. ErgoPay is implemented in the mobile wallet apps version 1.6 or up. A standard is defined for everyone to use, so we hope other wallets will follow. So we begin with a short demonstration how ErgoPay works, and for this I implemented an example dApp. So on the left hand side you can see my example dApp I've prepared for this. I hope you are not underwhelmed. I'm really a mobile developer, not a dApp developer, but I did the best I could. On the right hand side you see a connection to my mobile device. Testnet wallet is open, that's why it's blue, and I have two wallets already restored with some tokens, and my showcase dApp for ErgoPay can burn a token. And to burn a token I must first connect an address, and I could do this by hitting this open wallet button if I had an ErgoPay compatible wallet application installed on this machine. I don't have. That's why this German error message tells me that Firefox couldn't start any application, probably because software needed is not installed, which is absolutely right. But I have my Android device here, and I'm going to scan the presented QR code here. Okay, it's showing that I have an ErgoPay request, and I choose the first wallet to use. And the connection was done. On my mobile I have a hint saying that I can continue using the dApp, can dismiss it, while here in my showcase app the chosen address is shown and I can select the token to burn, same tokens that the wallet app on the mobile device shows, and I could burn any token. Everything is a fake testnet token. Even the Kushti token here is just something I minted on my own. But I'm going to burn this emoji token it's showing much more amount here than here in the wallet application. That's because decimals are not taken into account here. This emoji token is minted with 5 decimals. The wallet app makes a nice formatting and trims the zeros that are not needed. Here it's shown as a raw value. When I change this number, the QR code changes, but I can use it like this and scan this QR code. It asks again what wallet I want to use. That's because I was still on the overview screen where all wallets are shown. Now it's requesting data again. And now the interesting part is message from dApp. Set this transaction to burn the selected tokens. 250 emoji tokens and the transaction fee of 0.001 ERG will be withdrawn when I confirm. I do this, okay. Screen went black because of security. And now it's confirmed and the token will be burned. Okay. That was easy. And that's how it should be. Users of your dApp should have a convenient experience. And I will now show you how you can do this in your dApp. Before we start up the development environment, I wanted to spend some words on how the dApp connectors usually work, because ErgoPay works a bit different than the usual web dApp connectors. A web dApp connector consists of the following parts. We have a dApp user interface that's living in your browser. The web extension wallet also lives in your browser. We have a server that serves the dApp, usually a web server. And of course, we have the blockchain consisting of nodes. And that's how the communication flow works with the web dApp connectors. The dApp UI interchanges data with the web server that hosts the dApp. The dApp UI in the browser interchanges data with the wallet, which addresses are set up, what unspent boxes are available for these addresses, and the wallet extension interchanges data with the blockchain. Now, ErgoPay has to work different because we don't have this browser layer where both the wallet and the dApp live. So it looks a bit different. We have the browser with the dApp UI, still the dApp web server, blockchain, and the wallet. But the wallet is completely separated from the browser, and the dApp, the wallet can be on a completely different device, like in my demonstration I gave. So we still have data interchange between the wallet and the blockchain, of course, and of course between the dApp interface and the dApp web server. But now the data between the wallet and the dApp has to flow different. The dApp UI can give information to the wallet. This was the QR code I scanned or the button I pressed, and then the wallet application will make a request directly to the dApp web server and get a response what has to be done, and this was what has to be done is different than with the web dApp connector. It already contains a completely built Ergo transaction. So the dApp server has to interchange data with the blockchain to build this transaction. This is a bit more complex for the dApp, but the dApp knows best what it wants to do for the user. So it has advantages for the dApp to directly communicate with the blockchain. That's why I made some gray areas here too, because I think in many cases the dApp will interchange data with the blockchain anyway, because the data that can be provided by the wallet application is not sufficient for the dApp in many cases. So we see we have some logic that we have to implement here on the dApp server for ErgoPay. Such a web server can run different programming languages or frameworks. You are basically free to use whatever you like on the server. For this demonstration, I choose to work with Spring. They have a nice website here. Spring makes Java, a lot of buzzwords come up, but it works really easy. That's why I've chosen it. I've chosen Java because on the one hand I am familiar with it, but even more important is that one of the two SDKs for Ergo are based on the JVM, the Java Virtual Machine, so it's easy to work with the Ergo SDK from Java. Spring is a framework for Java that can build web servers. We need a simple REST API for ErgoPay, and that's where Spring excels. They have a QuickStart here that I recommend you to do. They tell you what you need to start. Probably you already have most of this installed. An IDE. I will work with Android Studio here, which is a derivative from IntelliJ, which is recommended here. And you need a Java development kit. If you don't have something installed, you will find links here, but I wouldn't use this JDK they recommend here, but would go with OpenJDK. I will add links to this tutorial for you. So to start a Spring Boot project, we head over to the Spring Initializer, very convenient. You don't have to change the project metadata here. You can leave it at com.example demo or insert your own stuff. The Java version is important. set it to the Java version the JDK you've installed supports. If you are not a fan of Maven, I would recommend you to switch to Gradle, but that's not mandatory. But what we really have to add here is the Spring web dependency. Here it's written build web including RESTful applications. And that's exactly what we want to do. So add the Spring web dependency and then hit generate. You will be able to download the zip file, extract it, and then open it in your IDE. So I just opened the extracted Spring project here with Android Studio, which is more or less IntelliJ, but with an Android flavor. It begins to download everything that's needed, which is good, so I don't have to do it. And we can take a look at the Spring project. Although it's not synced, now it is, and the Java objects are so that I have all convenient features. Okay, we just have a main class that's used to start the application. It's annotated with Spring Boot application, and that's all you need to have to start a Java app. If we start it, which can be done here with Gradle task, where have they? Here's bootjar, boot run. It's normally just boot run. Here on the application it is. You can just double click here and everything will compile and start. And you see you have a web server started at port 8080. And that's on localhost. Localhost 8080 will give you an error page. Yeah, we have not defined anything, so that's correct. It doesn't write here that we had an error, but we have to do something to make it live. I stop this here, so we can implement an REST API in every class that's on the class path just by annotated with REST controller, and we just add a public method returning a string hello and return hello world. So how is it called? We can use Spring Magic, annotate it with get mapping hello world. We start this. The last Gradle task we used is already inserted here, so we can this time just start up here. Start it again, go back to Firefox, and we open hello world, and it's returning hello world, and believe me or not, it's exactly what we've written here. So that's already the QuickStart tutorial of Spring, what we've done here. I will now reorganize this demo application a little bit, move the REST controller into an own class, and paste some helper methods so that we can start with ErgoPay implementation. Okay, my preparation is done. What have I done? I've just added a new object, ErgoPay controller, annotated as REST controller, so we don't have all clutter in the demo application. And I've added an ErgoPay response file, which is defined in the standard that defines ErgoPay. Instead of responding with a simple string like we did for our Hello World example, we have to respond with an ErgoPay response, and it has different fields. All are optional. Message for the user, message severity, P2PK address, the transaction that is prepared from our dApp, and an optional reply to URL where the wallet will set an answer when the user uploads the transaction to the blockchain. We won't use all these fields, but we will just make a little demo response. We begin with a public method again. As said, it should return an ErgoPay response, not a simple string. ErgoPay test. We have to annotate it with get mapping to make the string magic work. We will just make it live under ErgoPay test, and we will return an ErgoPay response, and we will just set a nice message that we expect the wallet to show. Okay. Oh, my application is still running, so I have to restart it. We go to the browser, and when we now enter ErgoPay test, we see that our ErgoPay response is returned. So now we want this in our wallet application, and for this we have to create a QR code. Now, instead of beginning with HTTP, we have to prefix this ErgoPay for the wallet application to know that it's an ErgoPay request coming. And the more technical advanced viewers will know that localhost is this address works only on the machine I'm actually on. For my mobile phone to connect to my Spring instance running here, I have to give it the IP address of the machine I'm working here. And of course I have to construct a QR code. I can do this with code, but for just one-time tests, I'm usually going to a website and let it generate it for me. We just have to use website URL here on qrstuff.com, but you can use most of websites. As said, it has to start with ErgoPay, the IP address of my machine here, if I remembered it correct. the port 8080 has to be the same, and we had ErgoPay test. So where's my preview? No preview from me. Okay, problem solved. Whatever it was, at restart solved it like usually. So I can now scan the QR code that I made for my ErgoPay URL and choose a wallet I want to make the action. Of course, you know, it's just a static test response we are giving. We don't really need a wallet address, but our wallet application doesn't know what will happen, so it asks anyway. And now we got the response. Nothing to see here. dApp still under construction. What we expected. Okay, that's nice. You see, you can talk to an ErgoPay compatible wallet application very easy. And now, of course, we want to build a transaction that the user can sign with the wallet. Okay, for making a transaction, we will use AppKit, the Ergo SDK I already mentioned. We have to write a bunch of code for that, and so that you don't have to reinvent the wheel. You can use everything I already presented from the written tutorial that accompanies this video, and I will use some stuff from it too. So in order to get AppKit working in our Spring application, we have to declare the dependency. I will copy the needed phrase for Gradle and go back to IntelliJ. And we have a build Gradle file. This file declares what Gradle should do with this project. And we have a dependency section where already Spring Boot Starter Web is declared. And we will insert one line that declares AppKit dependency. And when we hit sync now, it was very fast for me because the AppKit dependency is already downloaded in my Gradle cache. It might take more seconds for you. But now AppKit is on the class path and I can use everything that is inside it. For example, I know a class box operations. It's from AppKit and I can find it now. So I go to my ErgoPay controller and we will write a new method. Every ErgoPay endpoint have to return an ErgoPay response, and we will define a round trip. Our round trip should send an erg from an address to the same address, so it's just a round trip. We will define another get mapping here, round trip, and we want to have the address as an parent. Can use curly braces for this and to use this in our method we declare this with a pass variable annotation. Okay. We have to use more code. I will just copy this and we will explain it. This is a helper method. Okay. We need to add the imports. And this would work if we didn't have AppKit on the class path. Okay, everything's fine. Now, what is this? We build a transaction and reduce it and serialize it to send it to the wallet application. So this helper method will return a reduced transaction for an amount that we want to send from a sender to a recipient. And it's a difference if we are on mainnet or testnet, so this is another parameter this method has as an input. So what are we doing here? We create an REST API Ergo client that is an AppKit functionality. We give it a node URL. These node URLs are declared here, and this is Kushti's public node. It's his node. It's usually up, but of course, when you are creating your next big dApp, you should probably run your own node and then use your own node here. But if you just play around, you can feel free to use this. Network type needs to be given. It's mainnet or testnet. We don't give an API key. It's not needed. It's only needed for private methods of the node, which we won't use. And we give the Explorer API URL for the network type. So this creates a REST API Ergo client, fetches some information from the node, and then you can do something with the blockchain context that it gives you. What we are doing here is construct an Ergo tree contract for the recipient address, because our ERG that we want to send on a round trip will be sent back to the P to PK address of the sender. So we have to get a contract for this address. And then we use a helper method that is declared in AppKit in the box operations file, put to contract transaction unsigned, which does exactly what we want. It collects unspent boxes for a list of senders. We just give a single sender and send it to a contract address that we defined with the recipient address. Here's the amount that should be sent, and here's a list of tokens that should be sent, which we will leave empty. When this unsigned transaction is built, we reduce it and return it. So now we want to make the actual round trip. Das heißt, we will call our reduced send transaction method, and we need to know if we are working on mainnet or testnet. For this, we have to evaluate the address that we were given. So we can construct the address out of the parameter that we have here. Had a clash. Okay. So we know if we are on mainnet from this address. Can give it here. We want to send one erg. We have to give an nano erg amount here. So 1000 times 1000 times 1000 is 1 erg. The sender is our Ergo address and the recipient as well. Okay. This gives us a reduced transaction which we want to serialize to a byte array. And we save it in a variable. Okay, so far. And now, of course, we need to return our ErgoPay response. We do this exactly like before. And we want to catch all exceptions that could be thrown by get reduced syntax or by the address creation. For example, when the address string is not a valid Ergo address, this could throw an exception. When we have an exception, we set the return message to our exception message. And declare this as an error. If we have successfully created our serialized transaction, then we can give an information to the user that this was successful. And of course, we have to return the reduced transaction. Now, this is a string. Our serialized transaction is a byte array. So we have to base 64 encode it. Yeah. It has to be an URL compatible encoding that's defined in the ErgoPay standard. And this should be it. So we can start up our Spring application and check out if this is working. we have declared the address to use as a parameter, and now there's a little trick I didn't tell you before. ErgoPay defines a placeholder that the wallet application will use and replace by the user's address. And that's hashtag p2pk underscore address hashtag. Our wallet application used to scan the code will give us the transaction to confirm. Now you can only see the transaction fee and not the actual route trip. That's because the wallet application simplifies what's happening for the user, so he's not overwhelmed with information. And we withdraw one erg but set it back, so this is not shown because the amount actually sent is 0. If I confirm, this transaction will be sent to the blockchain, and of course you can change this to whatever you like and build other transactions. My example dApp shows how to mint a token or burn token, and it shows another important aspect that I won't cover in this video anymore, but you know how to get going and will find your way. What I didn't show yet is how to connect a wallet to your user interface, like I did with the burning token example. There's no other magic involved, it's just how to use the ErgoPay requests. And if you are interested, you can follow this guide and build it. Okay, so I hope you learned the basics about ErgoPay, and it would be awesome if you use it for your ErgoHack project. I'm looking forward to see what you are building, and if you have any questions, let me know.